Hi everyone and welcome to week 12 for higher level junior cycle. So this is going to be split into two parts, and the two parts are interpreting functions and then real life functions. So I'm just going to make a note of that. So the first part is interpreting functions, which is what we're going to be doing now. So if we take a look at the first example here. Now, first of all, when you see an x squared term in the function, that means that you're either going to get a u or an n, depending on whether it's positive or negative. So the x squared term means that it's going to be a quadratic, so it's going to be a curve. Okay, so if you see an x squared term, that means that it's going to be a curve. Now, you can tell whether it's going to be a u or an n-shaped curve. If the x squared is positive, then it's going to be in a U shape, like so. If the x squared term is negative, then it's going to be in an N shape. So you can tell by looking at the function straight away what type of graph you're going to be drawing. And as you can see, this particular function here, the f of x is equal to x squared minus 3x plus 2. Well, the x squared term is positive, so therefore it's going to be a U shape. Now, there's a couple of things you could be asked in relation to a function like you see on the screen there. If we wanted to solve the x values for the f of x equals 0, so if we were told that the f of x equals 0, another way of writing that is y equals 0. And if you were asked to find the corresponding values where y is 0, well, y is 0 where it cuts the x-axis, so it's going to be this point here and this point here. So those two values, when the f of x is 0, x is equal to 1. Sorry, I made a mistake there now. So x is going to be equal to 1 and x is equal to 2. So they're both the points where the f of x or y is equal to 0. Another thing you could be asked, if you were asked to find the value of the f of x for the point x is equal to 3.5. So if you were told that x is equal to 3.5, and you want to get the corresponding y value. Well, let's go to where 3.5 is on the graph, which is here where you see the red line. You're going to go up and see where it hits the curve and come across, and you get a corresponding value of 4 on the y-axis. Another example of that, if you were to find the values of x for which the f of x is equal to 3. So I'm going to write that question out. So find the values, and this is the way you'd get it in an exam question. So find the values of x for which the f of x equals 3. Okay, another way of writing the f of x equals 3 is y equals 3. So you need to go to the y-axis and see where y is 3, and it's here. You're going to come across and see where it hits the x-axis and come down. That's roughly 3.33. So your first value is x is equal to 3.33. And then if you come across again at 3, it also hits it here, and that's going to be roughly minus 0.3. So x is equal to minus 0.3. So both of those values are where y is equal to 3, and as you can see, because it's a curve, it hits it in two places there. So you can draw your horizontal line. You see they've done a green line there, so that's a horizontal line and it's parallel to the x-axis. Okay, so we're going to do an example now. So I'm just going to scroll down here. So if we look at this example, consider the graphs of the f of x is equal to x squared minus 5x plus 4 in red. So they're actually telling you there that the u is in red, so that's the quadratic function. So that's the f of x. I'm going to label that. So this is the f of x. And then in green, or in red, should I say? No, sorry, green. The green is the g of x. So the red is the f of x, and then the green is the g of x, which is x minus 1. So the g of x is in green, so I'm going to write that here, so the g of x. Now, you can actually tell as well which one is which, because if we look at the f of x, it has an x squared term, which means it's going to be in a curve. So that's your u shape, and because the x squared term is positive, it's in a u. And then if we look at this, it's in linear form. So the fact that it's in linear form means that it's a line. Now, what are they actually asking us here? They're asking us to solve the f of x equals the g of x. So at what point on the graph, or what points on the graph, do the f of x equal the g of x? Well, the f of x is this curve here, and the g of x is this line here. At what point do they equal each other? Well, it's the points of intersection. Okay, so I'm just going to write that down. So the f of x equals the g of x at the points. And you have 2 points here, as you can see on the graph. You have this point and you have this point, so at the points of intersection. Okay, so if we have to look at this point here, if we come down, so it's 5 on the x-axis, and we come across, and on the y-axis it's 4. So one of the points is 5, 4. And the other point is going to be, if we look at the x-axis, it's 1, and it's 0 on the y-axis, so the point 1, 0. So we can write that out in this sentence. So the f of x equals the g of x at the points 5, 4 and 1, 0. So that's a pretty straightforward question. It's kind of a standard question you get if quadratic functions is the type of function that you get. Okay, so we're going to go on to the next type of graph now. You can see this time the x squared term is negative. If we look at the function here, consider the function f defined by x is, or f of x going to 7x minus x squared in the domain 0 goes to 7, and x is the element of 4. We can graph the function as follows. Now, if we're looking at the function, it's 7x minus x squared. The fact that the minus, or the x squared is negative, means that it's going to be an n shape, n for negative. Okay, so if you were to graph that function, you'd put this into your calculator, and you'd get something like this, where you have an n-shape curve. So if f, so the function f, if f represented the height in meters of a golf ball above the ground, we'll say x seconds after it's hit, we could estimate that the maximum height of the ball from the graph is approximately 12.5 meters. So that point there, the maximum point of the graph is roughly 12.5 meters. Okay, so I'm just going to mark this in here. So the max height is equal to 12.5 meters roughly, and then usually there's a range there that you can, as long as you get it between two numbers, if it's within the range you'll get your marks. Now, if we wanted to estimate the number of seconds that the ball was more than 2 meters above the ground, so if we put, actually we'll just put height on the x-axis, I should have put this in first, so height, and then on the x-axis it's going to be time in seconds. Okay, so if we wanted to estimate the amount of time, or the number of seconds that the ball was more than 2 meters above the ground, so 2 meters is going to be here, height is in meters. If we wanted to estimate the amount of time that the ball was more than 2 meters above the ground, well, it was above 2 meters after this point here, so it's all of this area here. Okay, so we can draw a horizontal line at y is equal to 2 because you're told that it's greater than 2 meters. So we draw a horizontal line here. So I'm just going to write out what I'm doing here. So we want to estimate the number of seconds that the ball was more than 2 meters above the ground. So this is how I'm answering this question. So we draw a horizontal line at y is equal to 2, as you can see here. So we're drawing a horizontal line at y is equal to 2. Now at that point, let's see what our x values are. So this point here is going to be roughly 0.25. And this point here, come down, is roughly 6.75. So it was in between those two times that the height was greater than 2 meters. So the way we get that, the time that the ball spent in the air that was greater than 2 meters is going to be 6.75. Take away 0.25. And you get a value of 6.5 seconds. So you can actually answer the question. So the ball spent 6.5 seconds above 2 meters. So that's kind of a practical example of where functions come in, and that would be kind of a typical question that would come up in exam papers as well. So we're going to do another example now. So the flight of a golf ball is given by the formula the g of x is equal to ax minus x squared, for x is an element of R and it's plotted below. Find the value of a. Okay, so let's just write out our function. Our function is the g of x is equal to ax minus x squared. Now, if we look at the x squared value, it's negative, which means that it's going to be in an N shape, which it is. Okay. Now, what we're asked to do is find the value of a. So in order for us to get this, we need to pick a point on the graph. So any point at all will work. So I'm going to go for the point 1, 5, which is here. So I'm just going to pick that point, so the point 1, 5. And on that point, my x value is 1 and my y value is 5. So what I'm going to do now is plug that into this rule and we'll get a corresponding value for a. So what we have is the g of x is equal to ax minus x squared. Another way of writing the g of x is writing y is equal to ax minus x squared. So instead of y, I'm going to put in 5. So 5 is equal to a by, so my x value is 1, minus 1 squared. So then I get 5 is equal to 1a minus 1, because 1 squared is 1. So now what we want to do is get the a on one side and numbers on the other. So I'm going to bring the minus 1 over here, so it's going to be 5 plus 1 is equal to 1a. So then I get a value of a is equal to 6. Okay, so if you get something like that, you need to just pick a point on the graph. Now, you could have picked any point. You could have picked the point 2, 8 either, or you could have picked the point 3, 9. So any of those would have worked to get your answer there. So I think I have one more example before we do some questions. So the diagram below shows the graphs of the f of x is equal to x squared minus 4x plus 3 in red. So that's the f of x. I'm just going to label that. And then the g of x is equal to x plus k in green. So the g of x is in green. Solve the f of x is equal to 0 and then solve for k. So you have two parts to this question. So the f of x equals 0. So we'll just do this out here. So if the f of x equals 0, what's another way of writing that? We can write down y is equal to 0. So at what point does y equal 0? Now, instead of writing the f of x as well, so the f of x equals 0. So we have a formula for the f of x. So x squared minus 4x plus 3 is equal to 0. So we're actually going to factorize this. So sometimes that will come in handy. If we put in y is equal to 0, it actually doesn't help us here. So we're better off putting in, instead of the f of x, putting in our function and letting it equal 0. So we're going to factorize this. So we're going to open up our brackets. So we're going to put x in the first, x in the second. So factors of 3 that will add or subtract to give us 4. So 3 by 1, they're the only ones that are going to work. So if I put 3 and 1 here, and I'm going to put minus with both of them because I need a minus 4. Now if we take them out of the brackets, so x minus 3 is equal to 0, therefore x is equal to 0 plus 3, so x is 3, that's one of the solutions. So x is 3, and then x minus 1, so we say x minus 1 is equal to 0, so x is equal to 0 plus 1, so x is equal to 1, that's my other solution. So x is 1 and x is 3 on the graph. Now, next part of the question, so that was part A. So for part B, you are asked to solve for k. So you're asked to solve for k. So the g of x is equal to x plus k, and you are asked to solve for k. Now going back to the graph, if I was to mark in, we figured out that the f of x is equal to 0 at this point, and also at this point. And we found out that x is 3 and x is 1. So this point here is going to be 1, 0. And then this point here is going to be 3, 0. Sorry, I'm actually going to get rid of that point. We don't need that point at all. And that's not the point 3, 0. It's just 1, 0 that we need here. So we're going to use this point 1, 0. Okay, so we have the point 1, 0, and that's going to be my x value, and this is my y value. So what I'm going to do now is plug this into this formula here. So the g of x is equal to x plus k. Another way of writing that is y is equal to x plus k. So my y value is 0, so I'm putting that in instead of y, is equal to x. So that's going to be 1 plus k. So how do I solve for k? I'm going to bring the 1 over here. So k is equal to 0 minus 1. 0 minus 1 is minus 1. So my k value there is minus 1. Now before we move on to the actual exam papers, I just want to write down a couple of examples of real life examples of functions. So I'm going to give 2. So real life examples of functions. So a lot of students will ask this, like where are we going to learn this again, or where does this actually come up in real life? So the first example, if we say a phone bill was calculated at 20 cents per minute with a €12 fixed charge, so I'm going to write that down. So if we had a phone bill, so it's charged at 20 cents per minute with a €12 fixed charge, then we can represent the bill in euro as the f of x is equal to our standing charge, or our 20 cents per minute, so 0.2 by x, where x is the number of minutes, plus 12, which is our standing charge. So, or our fixed charge, should I say. So that's one example. Another example of a real life example of a function. So if we wanted to measure the height of a ball kicked in the air after x seconds. So measuring the height of a ball kicked in the air after x seconds. So we could use something like the g of x is equal to minus 3x squared plus 12x. Now looking at that, you can see that that's going to be in an n shape because it's negative x squared, and you can also tell that it's going to be a curve because it is the x squared term in the first place. So there are two examples of real life functions, and I suppose it's just important to be aware that they exist. So we're going to look at some exam questions now based on what we're after doing. Okay, so this question is taken from paper 1, 2013. So three functions, so we have the f of x, the g of x, and the h of x are defined as follows. So the rule for the f of x is 2x squared plus x minus 6. The g of x is x squared minus 6x plus 9. And then finally the h of x is equal to x squared minus 2x. So what we want to do is solve the f of x is equal to 0. So you're letting this equal 0. So we're going to write down, so 2x squared plus x minus 6 equals 0. Now you can probably guess what we're going to do here. We're going to solve this using a quadratic equation. Okay, so I'm going to solve this as a quadratic trinomial. So I'm going to use the guide number method to do this. So the way we do that is we multiply the coefficient of x squared by the constant. So 2 by 6 is 12. So factors of 12 are 12 by 1, 6 by 2, 3 by 4. So we need a pair of factors that will either add or subtract to give me the middle number. Now, that's the same as in 1x. So which one of these would work to give me 1? So 12 and 1 won't work, 6 and 2 won't work, 4 and 3 will work because 4 minus 3 gives you 1. So now I rewrite the equation. So 2x squared, and I'm going to rewrite it as plus 4x minus 3x minus 6 equals 0. And then what we do is we're going to factorize by grouping. So take out what's common here, so 2x. What multiplied by 2x gives me 2x squared? It's going to be x, plus what multiplied by 2x gives me 4x? It's going to be 2. So then I take out what's common here, minus 3x minus 6, so I'll take out a minus 3 because that's what's common. And what by minus 3 gives me minus 3x, it's going to be x. What by minus 3 gives me minus 6, it's plus 2. And as you can see, the same thing in these brackets, which is good. Your final answer is 2x minus 3 by x plus 2. And that's the answer to that first one there. So then solve the g of x equals 0. So we're going to let this equal 0. So x squared minus 6x plus 9, let that equal 0. So we're going to solve this as a quadratic. So factors of 9 that will add or subtract to give us 6. So 3 by 3, that's going to work. Just write out 9 by 1. So if we open up the brackets, put x in the first, x in the second. Now, if we use 3 and 3 and we need a minus 6, they both need to be minus. So x minus 3 and x minus 3. So our value here is x minus 3 equals 0. So x is equal to 0 plus 3. So x equals 3. Now I actually didn't solve the previous one, so just take it that step further. So 2x minus 3 equals 0. So 2x is equal to 0 plus 3. And then x is equal to 3 over 2. That's one of the solutions. And then this one here, x plus 2 equals 0. So x is equal to 0 minus 2. X is minus 2. That's your solution there. So when it says solve, you actually need to get answers for x. And then finally, solve h of x equals 0. So we're going to let this equal 0. So x squared minus 2x is equal to 0. So the way we solve that is we take out what's common. So what's common to x squared and 2x? Take out x. And x minus 2 gives us 0. So we let both of these equal 0. So x is 0 is one solution. And then this one, x minus 2 equals 0 is another solution. So therefore x is equal to 0 plus 2. So x is 2. So that's that one solved. So we're going to go on to another exam question now. So this is actually, sorry, this is the same question, but it's just part B. So the table below shows the sketches of 6 different functions, and 3 of the sketches belong to the 3 functions from part A. Write the f of x, g of x, or h of x into the box underneath for the correct sketch for each of the 3 functions. Now, let's just write down again. So the f of x, I'm just writing this from the previous question, was 2x squared plus x minus 6. And we got values of x is 3 over 2 and x is minus 2. That was our answer for that one. The g of x is x squared minus 6x plus 9. And we got values of x is 3 for that one. And then the h of x, so the h of x is x squared minus 2x, and the x values we got with that for that were x is 0 and x is 2. Okay, so we need to look here and see, if we look at the f of x, so the x squared term, first of all, that's positive because you don't see a negative sign there. So that immediately eliminates all of the n-shaped graph. So it's not diagram 1. Or it's not diagram 6. So it's going to be either diagram 2, 3, 4 or 5. Now, we know that the x value, so crosses the x-axis at 3 over 2, which is 1.5 and minus 2. So 1.5 and minus 2, this looks like it could be it. 1.5 and minus 2, this point and this point here. Let's just look at the other ones, the other U-shaped, so it's going through the origin there. So that's not going to be it because x is 3 over 2 and x is minus 2, so that eliminates that one. This one here, it's based on the x is 0 and our other x is a negative value, so that's not going to work either. And then finally, if you look at diagram 5, you actually are only going to have one point where it crosses the x-axis, so that's not going to work, so it must be diagram 3. So diagram 3 is the f of x. Now, if we were to look at the g of x, so the x squared term is positive, which means it's also going to be a U shape. So again, this eliminates diagram 1, it eliminates diagram 6, and it also eliminates diagram 3 because we've already dealt with that. So it's either going to be diagram 2, diagram 4, or diagram 5. So for the g of x, x is equal to 3. That's your only solution. X is equal to 3. So it must be that one there. You only have one x value. So that's the g of x. And then finally, for the h of x, x squared is positive. So again, you're going to know it's a U shape. So that eliminates the ends. And you've only either diagram 2 or diagram 4 left. Now your x values are 0 and 2. So it must be this one because x would be 0 there and 2 would be roughly there. If you were to look at that, this x is 0 and it's negative, goes into a negative value to diagram 4. So diagram 2 is the h of x. So another question now. So this is 2014, paper 1. So the graphs of the functions, the f of x is equal to x squared plus 2x minus 3, and the g of x is equal to minus x squared minus 2x plus 3 are shown below. Identify each graph by writing the f of x or the g of x in the space provided below the graph. So it's similar to the question we're just after doing. You have to figure out from the question which one is the f of x and which one is the g of x. So for part A, one of these is the f of x and one of these is the g of x. So it's actually going to be very straightforward for this one because you only have two graphs. One of them is a U shape and the other is an N shape. So the one that is U shape is going to be where the x squared is positive. So this must be the f of x. And then the g of x is negative. So this one must be the g of x because it's an N shape. So that's the g of x. Now if we go on to part B, the graphs of the functions y is equal to the h of x and y is equal to the k of x are shown below. Now this is a little bit trickier, so what you're being asked to do is write down the roots of each function. Now what the roots mean is where it cuts the x-axis, so I'm just going to make a note of that. So the roots is where the function or where the curve cuts the x-axis. So if we were to look at the h of x, it cuts the x-axis at x is 3 and x is minus 2. So x is equal to 3 and x is equal to minus 2. Now if we were asked to get the equation of the h of x, if x is 3 outside the brackets, it's minus 3 inside the brackets. If x is minus 2 outside the brackets, it's x is plus 2 inside the brackets. And that's it for the h of x minus 3 and x plus 2. And then if we look at the next one, the root of the k of x, so the x value is minus 3 and 2. So x is equal to minus 3 and x equals 2. And the equation, similarly, if it's minus 3 outside the brackets, it's plus 3 inside. If it's 2 outside the brackets, it's minus 2 inside. So that's it for the k of x then. And that's it for this week. So I'm going to attach some links into the chat just for some extra video tutorials for you to do. And just, I suppose, be very aware of what the different types of functions look like when you see them on a graph.